So in this video, I'm going to talk about gas mixtures and how we can obtain information about the individual pressures from each gas within the mixture, as well as the total pressure of all of the gases within that mixture. So when we think about mixtures, we previously talked about it in terms of your pure substance as well as your mixture and how mixtures could be homogeneous or heterogeneous. But a mixture simply indicated that we had two or more pure substances that were physically combined. So in other words, we had two or more things that were present. So now that we're talking about gases, we can still apply this concept. Gas mixtures indicate that we have two or more gases that are present within a sample or within a substance. And so when we're talking about mixtures of gases, we can think about Dalton's law. Dalton's law simply indicates that the pressure that each individual gas obtains or actually has, that observed gas for the observed pressure for the individual gases, if we total that observed pressure for each individual gas within a mixture, we can identify the total pressure of that mixture. So with Dalton's law, we can simply show it as P sub T. So P is our pressure. This subscript of T is just the total pressure. And so his law tells us that when we add the pressure of each gas within that mixture, it gives us the total pressure of that mixture. And so we can simply add based on however many gases we have present. The 1, 2, and 3 that I showed is just gas 1, gas 2, gas 3. Sometimes you'll have a gas mixture that only has 2 gases, but you could have a gas mixture that has 4 or 5. And so regardless of how many gases are in the mixture, the individual pressure of each, which is referred to as the partial pressure, those individual partial pressures can be added together to identify the overall or the total pressure of that mixture. We can think about a pie chart. So you've seen pie charts in math class, and so a pie chart allows you to see what part a substance represents out of the whole thing. So we can think of the whole thing as being our mixture. And so based on this pie chart that's shown here, each color, we can just imagine that each color represented a separate gas. So this gas mixture would have a total of 4 gases present. If we wanted to determine the total pressure of this gas mixture, we would simply add the partial pressure of gas 1 plus the partial pressure of gas 2 plus the partial pressure of gas 3 plus the partial pressure of gas 4. So the equation for Dalton's law is simply telling us that our total pressure is simply equal to the sum of the individual partial pressures. And so we can apply that concept as we work through an example. So in this example, it says a mixture of chlorine, oxygen, and nitrogen gases has a total pressure of 6.1 atmosphere. If the partial pressures of nitrogen and chlorine are 2.1 atmosphere and 1.5 atmosphere respectively, what is the partial pressure of oxygen? So if we think about what we have, it tells us that we have a mixture of 3 gases. So that means that when we're looking at our total pressure for this mixture, the total pressure is going to be equal to the pressure of the chlorine plus the pressure of the oxygen plus the pressure of the nitrogen. So this mixture has 3 different gases. So when we add up these 3 partial pressures, it should equal our total pressure. It gives you the total pressure, 6.1 atmosphere. So we can simply plug that into the equation. It tells us that it has partial pressures of nitrogen and chlorine, 2.1 atmosphere and 1.5 atmosphere respectively. So what that means is that the order that those gases are written follows the order in which the pressures are written. So nitrogen is first, so that first value applies to nitrogen. Chlorine was written second, the second value applies to chlorine. So that means that the partial pressure of chlorine is 1.5 atmosphere. So I can just plug that into the equation. We don't know the partial pressure of oxygen. That's what we're trying to find out. And it gave us the partial pressure of nitrogen, which was 2.1 atmosphere. So from there, we can simply do our algebra. I'll go and show the extra steps just to make sure everyone understands where the numbers are coming from. I didn't do anything on the total pressure side of the equation. I can combine the partial pressures of chlorine and nitrogen. And so when I add that 1.5 and that 2.1, it gives me 3.6 atmosphere. I still don't know the pressure of oxygen. And so in order to determine the pressure of oxygen, I need it on one side of the equation by itself. Right now, I'm adding that to the 3.6. So I have to do the opposite to get it by itself. The opposite of adding is to subtract. So when I subtract that 3.6 atmosphere from the right side, I have to make sure that I do the same thing on the left side. So again, we're just doing algebra. So on the right side, that cancels out, leaving me with simply my partial pressure of oxygen. On the left side, I have to find the difference. So 6.1 minus 3.6 to give you 2.5 atmosphere. So what this tells us is that in this mixture of these three gases, the chlorine had a partial pressure of 1.5 atmosphere. The nitrogen had a partial pressure of 2.1 atmosphere. So that means that our oxygen had a partial pressure of 2.5 atmosphere. You can always go back and double check the math to make sure that now that you know that there were three gases present and you now have partial pressures for all three gases, add them together and make sure it adds up to your total pressure. And in this case, it does. So if you know information about the individual gases within a mixture, you can find out other unknown information. In this case, we knew what the total pressure was, and we knew the partial pressures of two of the three gases that were present. So therefore, we can use that information to find out the partial pressure for the remaining gas. However, we could have also done an example where we know the individual partial pressures and we need to figure out the total pressure. You're going to use the same equation. And so that equation is still going to be used, but we're now filling in different information. So in this example, it says a mixture of gases contains nitrogen and oxygen. What is the total pressure of the mixture if the nitrogen and oxygen have pressures of 3.4 atmosphere and 4.8 atmosphere, respectively? So again, here we have a mixture, but this mixture only contains two gases. It tells us that it contains nitrogen and that it contains oxygen. Now, I'm putting the N and the O for nitrogen and oxygen. If you wanted to put P1 and P2, that is fine as well. The key is that we only have two gases present, so we should only have two partial pressures that contribute to the total pressure. And so we don't know the total pressure because the problem says, what is the total pressure? We don't know that, so I'm going to just keep my P sub T, but we do know the partial pressure of the nitrogen and the oxygen. Again, it gives you both values. It's written respectively. Since nitrogen was written first, the first value corresponds with the nitrogen, so 3.8 atmosphere. Second value corresponds with the oxygen, 4.8 atmosphere. And so from there, you're simply finding the sum of those two values. So you're just adding the 3.4 and the 4.8, and when you add those two, it gives you 8.2 atmosphere. So what this tells us is that the total pressure of this mixture is 8.2 atmosphere. We only had the two gases present. The nitrogen contributed 3.4 atmosphere. The oxygen contributed 4.8 for a total of 8.2. And so when dealing with Dalton's law and the partial pressures, we can have the actual values for the pressures. So we can look at atmosphere, we can look at torr, we can look at millimeters of mercury. You can also see partial pressures presented in percentages or even with respect to the mole. So if I go back to that pie chart, we could have converted this to a percentage. It's still telling you the same information. So for instance, if we know that we have a total pressure of 10 atmosphere and that one gas contributes 50%, we just multiply that 50% times 10, which would be 5. So that means that that one would have a pressure of 5. So it's the same process, same concept. Again, Dalton's law is just telling us that the total pressure is equal to the partial pressures of the individual gases that are present. So I hope this helps. If you have any other questions, please let me know. Thank you.